So in this video I want to look at a particular type of C-mode operation that we can work with in the simulator, which is called a sequence file. And we're not going to get into a lot of details about how you create a sequence file, but let me show you briefly first of all what it looks like. So here's a particular file called cross.sequence. It has some header information, standard strings, user information, version of the truth table we're using, 2 dimensions, the labeling of the sides, and our actual particular data begins here. We say that we're driving 4 channels on our matrix, and then we list those 4 channels. So we're going to drive the data west inputs on cells 0, 0, 1, 0, and 2, 0, and we're also going to drive the control west input on cell 1, 0. And then we have a series of 4 tuples. Each of these strings contains 32 hex digits, that's 128 bits, ordered starting from the left to the right. And basically we take the first bit in each of these 4 strings and we apply it to these 4 inputs and then tick the clock. And then we apply the second bit to these 4 inputs, tick the clock, apply the third bit to the inputs, tick the clock, and so on until we've gone 128 clock cycles. The effect of these first 4 strings would be basically to set the control west input on cell 1, 0 to be all 1s, and each clock tick to set the data west input on that cell to a pattern of all 0s for the first 64 ticks, and then an alternating pattern of 0, 0, 1, 0. What this is actually doing is causing this cell 1, 0 to assert a C output, and that's being used to configure another cell next to it. So after this first 4 tuple is executed, we go on and we read the next 4 tuple, and that will set the inputs up here and tick the clock in between each one, and so on and so forth. A sequence is really just a collection of bit patterns that are sent to one or more cells in order to achieve some kind of behavior throughout the matrix. The way that this file was generated was by using a series of Java classes that let us specify exactly what operations we wanted to perform. So let's take a look at what this sequence file does, and then we'll talk a little more about its creation. And since this is supposed to bootstrap an 8x8 circuit, it's going to bootstrap the crossbar network that we looked at earlier, I'm going to put in an argument that says, let's make the size of the matrix actually 8x8. So I'll do this, and here's our graphic window, and now if I extend this, you'll notice that the matrix ends after the 8th row and the 8th column. This means that I can access the inputs of cells on the east or on the south, as well as the north and west. Now if I say sequence cross.seq, it will begin feeding these input patterns to these 3 cells inputs, the D and C inputs. And what it's doing is making what we call a multi-channel wire. Now we'll talk about this more in the wire building unit, but basically we're configuring these sets of cells to give us access to other cells, ultimately so we can make a turn in this wire and configure regions to the south, which we will use to give us access to these cells in the rightmost column. And what we're doing is we're bootstrapping these cells to be part of our crossbars. You just take inputs and pass them to outputs on the opposite side. And whereas this cell is initially empty, after it's configured, it takes on that crossbar pattern. And this sequence will continue until it's configured all of these cells at the bottom of the column. And then this wire will back up a little bit. So we've got one more configuration to make. And now we backed up to this point and we built our wire, and instead of making a turn, we moved further over straight so that we could configure these 3 cells. And this cell has some unusual pattern in it right now, but if we look at it again, it's been configured as a crossbar, as has this and this. And now our wire goes back to the beginning and we repeat this whole process. So this is going really slowly because I have a screen capture running in the background, but I can speed it up by modifying the update rate. Now normally things are updated every single time that there's an event. So if I look at you, current update rate is 1. Basically every clock cycle we update all the changes in here. But if I change my update rate to 128, then things will be updated only every 128 clock ticks, which means that after that entire pattern of bits has been loaded in for one of those 4 tuples, then we'll update the graphic window. So this will run quite a bit faster. So now I can say sequence cross.seq, and you can see a little better what's happening as it moves over, turns, goes to the south, and each time it does that, it configures another row, another column of cells. This will go on until it's configured all 5 of these, and then it will use a different sequence to configure these last 3 columns. And then it's done. And now we've successfully built a crossbar network. We can assert any of the inputs on the edges, and it moves all the way through the matrix. And if we just point at these different cells, you can see in the title bar all the truth tables are identical. So that's the super sequence. And the way it's created, it used to be created on large sheets of paper. We would sketch out all these cells, figure out by hand what bit patterns we needed to send in order to perform these wire building operations and these configuration operations, and you would use a different sheet of paper for each set of 128 clock ticks, and that was a very laborious process. Now it's all fairly automated. You can write a Java program and invoke these wire building classes to let you say things like initialize a 3-channel wire that's initially facing to the east, extend it 5 steps, make a turn clockwise, extend it 1 more step, and now transfer this element from this binary file to the east of the head of the wire. And so you can define all these super sequences, collections of sequences, and there's a standard bootstrap super sequence. And in fact, there's a file you can just say boot and give it the name of a binary file, and it will generate this sequence file. That's how cross.seq was actually generated. So that's an example of more complex C-mode operations illustrated inside the Java simulator. And as I say, there's a special unit dedicated just to wire building, and in that unit we'll talk more about the particular details of sequences and sequence generation and super sequences.